Welcome to the debate. When forensic scientists examine a disputed artifact, say a potentially forged medieval document or a supposedly ancient painting, there is this fundamental expectation of mechanical consequence.
Right, cause and effect.
Exactly. If you look closely enough under a microscope, the physical world always leaves a legible signature. I mean, you find the tool mark, you find the directional brushstroke, or, the uneven pooling of a chemical dye.
Or the cracked edges of a pigment binder. The universe rarely hides its math completely. Every physical action leaves a fingerprint of the process that created it.
Right, up until you step into the world of the Shroud of Turin, specifically the body image on that linen. Suddenly, those foundational forensic signatures, well, they start to contradict each other.
They do. It's a notoriously difficult material to study.
We are looking at a diagnostic landscape where the closer you look, the more the laws of physics seem to actively fight our current models. So today, we are examining the exact formation mechanism of that body image.
And the core question we're tackling is really this. Can the shroud's uniquely interdependent properties be explained by refining our existing scientific and historical hypotheses? Or do rigorous analytical filters prove it remains completely unexplained?
Right, and my position today is that demanding what we call simultaneous consistency, where a single mechanism has to account for all spatial, chemical, and topographical data without contradiction, that effectively rules out all known artistic, optical, and natural hypotheses. We have to reject the composite fallacy.
And I come at it from a slightly different angle. I'll be arguing that while quantitative filters are excellent for pruning weak theories, strictly dismissing modified chemical or natural processes as composite fallacies is dangerous. We risk abandoning our most viable evidence-based explanations just because of minor unresolved environmental variables.
I see why you think that. But let me clarify my stance. Demanding simultaneous consistency isn't looking for a magic bullet. It's the bare minimum of scientific rigor. If you propose a mechanism, it must account for everything simultaneously.
Let's lay out what those specific constraints actually are for the audience, though, because the baseline data established by the STURP team back in 1978 really is indisputable at this point.
It is.
First, you have this extreme superficiality. The discoloration on the cloth is limited strictly to the outermost 0.2 to 0.7 micrometers of the linen fibrils.
Let's pause there, because we really need to visualize how insanely thin that is. A single thread of linen is made up of hundreds of smaller, microscopic fibrils. The image on the shroud doesn't even penetrate a single fibril.
It sits entirely on the outermost microscopic surface.
Yeah, absolutely no capillary flow. I mean, if you paint a piece of cloth, the liquid wicks down into the threads. There is none of that here. There are no pigments, no binders, no paints.
What we are actually looking at is an oxidation, a dehydration and conjugation of the cellulose itself.
Which essentially means the structural sugars of the plant fibers have chemically broken down and aged. Think of a sliced apple turning brown when you leave it on the counter. It's a chemical alteration of the material itself, not an applied layer of color.
Right.
And add to that the fact that the bloodstains definitively precede the image.
And that is a crucial bottleneck for literally any theory.
It is the ultimate bottleneck. The body image formed around the blood, not under it. Whatever mechanism created the brown image had to happen after the blood had already coagulated on the cloth.
Without chemically altering or, destroying those blood clots.
Exactly. And of course, this image had to survive the extreme heat of a recorded church fire in 1532. Without the body image changing color or burning the way medieval pigments would under high temperatures.
So the physics and chemistry of the cloth are what they are. Nobody is debating the raw data. Where our positions actually diverge is on the standard of proof for explaining it. You insist that a single unified mechanism must satisfy all these constraints perfectly all at the same time.
Because the moment you don't, you fall into the composite fallacy. People try to splice together partial explanations. They say, we can get the 3D geometry right by manually rubbing a bas relief sculpture, and then we get the superficial browning by using a chemical acid wash.
But you think those steps inherently conflict.
They fundamentally conflict. You cannot build a solution by peeling the stickers off a Rubik's Cube and gluing them back on to make the colors match. You violated the mechanics of the puzzle to get there.
Well, I just don't buy that analogy. Complex natural phenomena almost always require a layered understanding. Asserting that refining a natural process, like accounting for different skin chemicals reacting with a draped cloth, constitutes some ad hoc failure is overly dismissive.
Is it?
I mean, we don't throw out the theory of planetary formation just because we have to tweak our models of atmospheric gas distribution. We just refine the model.
But refining a model is entirely different from ignoring a direct physical contradiction. Let's look at the first major analytical filter that completely shatters the artistic or contact hypotheses: Fourier analysis.
Ah, the JPL study.
Yes, back in 1977, researchers at the Jet Propulsion Lab ran Fourier analysis on digitized images of the shroud. What the fast Fourier transform does is decompose an image into spatial frequencies. It's essentially a mathematical tool that hunts for hidden patterns of directionality.
Right, it maps brightness variations by direction and scale. It looks for the math behind the stroke, basically.
Exactly. And what they found is that the body image and the bloodstains have a nearly continuous, radially symmetric power spectrum. In scientific terms, it is completely isotropic. It lacks any preferential directional biases whatsoever.
Meaning no left to right brush marks, no up and down rubbing patterns.
Think of it like trying to rake a traditional Japanese Zen garden. You're manipulating the sand into a perfect portrait, but doing it without leaving a single linear rake mark behind. It is physically impossible.
Because the tool leaves a mark.
Always. Any manual application, a brush stroke, a rubbing block, a heated tool for scorching, inherently introduces microscopic, anisotropic spikes in the data. You leave pressure variations where your hand pushed harder. Because the shroud is perfectly isotropic, manual artistic contact is ruled out completely.
That is undeniably true for traditional painting or, aggressive manual rubbing. If someone scrubbed pigment into the cloth, the Fourier transform would light up like a Christmas tree.
It absolutely would. But let's look at recent advancements that challenge this rigid dismissal. In 2025, digital modeling by Moraes demonstrated that low-relief templates significantly reduce the macroscopic wraparound distortions you get when draping cloth over a full 3D body.
I'm familiar with the paper.
So if we assume a low-relief template, could a highly uniform, gentle application of heat or pressure avoid those obvious strokes and yield the isotropic spectrum we see? Even Jackson's team back in the 80s noted that heated bas relief tests produced an initial resemblance to the shroud's 3D properties. If the application is perfectly uniform, you might avoid the anisotropic spikes. That's an interesting point, though I would frame it very differently. The Moraes study from 2025 was rigorously dismantled in 2026 by Casabianca, Marinelli, and Piana, precisely because Moraes only addressed the macroscopic geometry.
He looked at the drape.
Yes, but he completely ignored the crucial superficiality of the image and the precedence of the bloodstains. Let's say you heat a bas-relief statue to singe the cloth. Heat travels. A scorch does not limit itself to the outer 0.2 micrometers of a fibril. It penetrates.
Which is why the strict contact hypothesis struggles with the chemistry, yes?
Furthermore, when we look at real physical life-size bas-relief tests, not just digital geometric models in a computer, they fail the topographical test completely. Have you looked at the VP8 image analyzer results for a physical bas-relief rubbing?
The gradients are off, I know.
You don't get the smooth gradient of the shroud. You get sudden plateaus and hollows because the cloth bridges over the gaps in the physical sculpture.
Okay, but if physical contact fails because it leaves a pressure footprint or a heat gradient, where does that actually leave us? It pushes us toward a mechanism that doesn't physically touch the cloth to form the image.
Which leads to?
Which brings me to the passive optical projection hypothesis, the camera obscura or the proto-photography idea. This entirely bypasses your Fourier issue if the image is projected via a simple lens or a pinhole onto a chemically sensitized piece of linen in a dark room. It is entirely non-manual.
Right, no tool marks.
Absolutely no tool marks. It perfectly satisfies the demand for an isotropic Fourier spectrum. And theoretically, an optical projection naturally encodes distance via optical falloff.
How so?
Well, as body parts are further from the lens, the light intensity naturally drops, creating a fading effect. We've seen fascinating replications by researchers like Alanik that produced negative images with remarkable anatomical detail.
I see why you'd point to that, but let me give you a different perspective on what the VP8 image analyzer actually does. Because this is the exact moment where the optical theory collapses entirely.
I'm listening.
There is a massive public misconception about the VP8, which Jackson and Jumper famously used in 1976. The general public hears VP8 and thinks it takes a flat 2D photo and magically builds a rotatable, photorealistic 3D sculpture. It absolutely does not do that.
No, it's purely a topographical relief mapper. It correlates image density to a z-axis.
Right. It creates a relief graph where image intensity strictly mathematically correlates with vertical distance. Darker equals closer, lighter equals further away. If you take a normal photograph of a human face or a camera obscura projection and you feed it into the VP8, the output is a grotesquely distorted monster.
Because of the shadows?
Because of the shadows. Optical projections embed lighting directionality. If your light source is shining down from above the subject, the underside of the nose casts a deep shadow.
And that shadow is dark on the negative.
Exactly. The VP8 looks at that dark shadow and says, dark means close to the cloth. So the resulting 3D graph shows a face with a huge, unnatural block protruding from underneath the nose. Schwartz noted exactly this regarding Ellen's optical replicas. They contain severe directional artifacts from the illumination geometry.
Because the light source dictates the density, not the physical distance from the lens.
Bingo. The shroud, however, produces a clean, anatomically plausible relief completely absent of any lighting-derived artifacts. There are no cast shadows. The density of the discoloration is purely a function of cloth-to-body distance. Optical theories fundamentally fail the VP8 filter.
Well, I will concede the point on optical projections. The lighting artifacts are a fatal flaw for the camera obscura model. But notice what we've done here. We've eliminated physical rubbing because of pressure marks, and we've eliminated light because of shadows.
Which leaves very little room.
Which brings me to what I consider the strongest argument, and where I think your strict composite fallacy framework becomes overly punitive. The Maillard reaction.
The natural chemical browning model.
Yes. Rogers demonstrated this beautifully in 2003. Let's walk through the chemistry. When a human body begins to decompose, it rapidly releases volatile amines, essentially ammonia-like gases.
Standard decomposition, sure.
Now, historically, ancient linen manufacturing used a soap weed called saponaria to wash the threads, leaving behind a thin residue of carbohydrates and sugars on the very surface of the fibrils. When those volatile amines from the body waft up and react with those surface sugars, you get a classic amino-carbonyl browning, the Maillard reaction.
It's the exact same chemical process that makes the crust of bread turn brown in an oven.
Exactly. And it explains the color perfectly. But it does more than that. This is a passive, completely directionless chemical process. Gases diffusing through empty space do not leave brushstrokes. They guarantee the strong Fourier isotropy we observe.
Assuming an even distribution of gas, yes.
And crucially, gas diffusion natively encodes distance for the VP8. Gas diffusion is proximity dependent. The closer the cloth is to the skin, the higher the concentration of amines hitting the linen, and the darker the chemical browning on the fibrils. It creates a perfect intensity-to-distance gradient without any lighting artifacts or cast shadows.
In a perfect vacuum, perhaps. But let's look at the actual physics of gas diffusion. When a gas diffuses across a gap between a warm body and a cooler cloth, you inherently introduce convection currents. You get turbulence.
Well, in an open, windy environment, sure. But under a heavy linen drape inside a sealed rock tomb, those currents are highly stable microenvironments.
But they still exist. And they blur the chemical transitions. Gas diffusion models yield significantly softer gradients on the VP8. You get plateaus where the gas pools in the folds of the cloth, or you get inconsistent coherence around the sides of the face.
It's not a perfect mapping, I'll admit.
It completely misses the shroud's incredibly sharp, precise intensity-distance function. Even Rogers himself admitted that while his chemistry neatly explains the extreme superficiality of the color, it struggles to fully explain the high-resolution, quasi-photographic quality of the image.
Which is exactly why subsequent researchers didn't just throw their hands up. Kira's work showed that incorporating skin amines, direct contact proteins like squalene, rubbing directly onto the cloth where it touches the nose and forehead, improves that resolution significantly.
And there it is.
To me, that is not a composite fallacy. That is the normal scientific process of refining a model to match empirical reality. If a cloth is draped over a face, it will physically touch the tip of the nose and it will hover a millimeter above the cheek. You inherently have both direct contact and gas diffusion happening simultaneously.
And this is where the Rubik's Cube falls apart. What you just described is the textbook definition of the composite fallacy, and it is precisely why these models fail the simultaneous consistency test.
How is refining the contact points a failure?
Because you can't just slap a contact step onto a gas diffusion model to fix your blurry resolution without destroying your other data points. If you fix the blurry resolution by relying on contact-transferred skin proteins, you instantly reintroduce directionality.
I don't see how.
Contact requires weight. Weight means pressure. Pressure varies across the topography of a face. The moment you rely on physical contact for the high-resolution areas of the image, you ruin the Fourier isotropy. You introduce the very anisotropic pressure spikes we just agreed are completely absent from the shroud.
Well, I'm not convinced by that line of reasoning. You are assuming that the direct contact of a cloth draping naturally under its own weight behaves the same way as a manual rubbing or a bas-relief tool.
It's still physical contact.
But a linen falling passively onto a face covered in natural skin oils does not involve a lateral side-to-side rubbing motion. It doesn't involve the dragging of an artist's tool. Therefore, it does not necessarily produce the anisotropic spikes that Lin and Lohr were hunting for. A vertical, gravity-driven contact is vastly different from an artistic intervention.
But even vertical draping creates massive pressure differentials. Think about it. The bridge of the nose bears significantly more weight per square millimeter than the gentle slope of the cheek. That pressure differential alters the saturation of the fibrils.
Right, but
If the image intensity on the nose is dictated by heavy physical contact, but the image intensity on the cheeks is dictated by a gaseous cloud of diffusion, your VP8 topographical map would show a massive, jarring discontinuity between the two zones.
why a discontinuity? It's the same chemical reaction.
Because the delivery mechanisms operate on completely different physics. But the shroud image doesn't show two separate systems patched together. It shows a continuous, uninterrupted mathematical relationship between distance and density across the entire anatomy.
But the transition...
You cannot mix and match conflicting physical realities to patch the holes in your theory. If you try to fix the chemistry by heating the cloth, you alter the blood precedence because the serum halos and clotting would be cooked or chemically altered by a high-heat mired reaction happening after the blood transferred. The properties are non-modular.
That's a compelling argument, but have you considered that the transition between direct contact chemistry and millimeter gap gas diffusion chemistry is just a smooth gradient?
How so?
The Maillard reaction is driven by concentration. Whether the amine concentration is transferred via direct fibril to skin contact or wafted over a 1 millimeter air gap, it is the exact same chemical reaction occurring on the exact same 0.2 micrometer surface layer of the saponaria residue. The chemistry scales seamlessly.
In theory.
You are demanding that a single delivery mechanism do all the work. I am saying the mechanism is the chemical reaction itself, and the delivery method is just the natural gradients of physical reality.
Look, I hear what you are saying about the chemistry theoretically scaling, but the empirical testing flat out rejects it. No full-body replica under realistic drape conditions has ever passed both the Fourier and the VP8 filter simultaneously while also maintaining the extreme halftone fibril selectivity we see on the shroud.
Oh, we should probably clarify halftone fibril selectivity for the listeners because it is bizarre.
It is deeply bizarre. When you look at the shroud under high magnification, any individual microscopic fibril is either fully discolored to its maximum brown or it is not discolored at all.
There are no light brown or dark brown fibrils.
Exactly. The macroscopic shading, the reason the tip of the nose looks darker than the cheek, comes entirely from the number of discolored fibrils per unit area. It operates like a newspaper halftone print. Gas diffusion models struggle immensely to replicate that binary on or off effect without accidentally saturating the deeper underlying fibers in the thread.
Which highlights exactly where we are in the scientific process and why I remain optimistic. Acknowledging that Fourier and VP8 analyses effectively dismantle traditional artistic and optical theories is a massive step forward. We are in agreement there.
The rubbed bas relief fails. The camera obscura fails.
Yes, but I maintain that the Maillard chemical reaction remains incredibly compelling for the superficiality, the halftone color, and the total lack of pigments. Suggesting that slight, yet-to-be-replicated environmental conditions bridge that gap between diffusion blurring and the shroud's sharp VP8 graph is not a composite fallacy.
So you think it's just a matter of finding the right environment?
Yes, perhaps highly specific humidity levels within an enclosed limestone tomb, or a specific thermal gradient of a cooling body. It's just an honest acknowledgement that we haven't perfectly simulated a highly specific, ancient microenvironment yet.
And I will summarize my position by reasserting that the methodological error of assuming partial explanatory success allows for ad hoc combinations. It must be retired entirely. The simultaneous consistency demanded by the isotropic Fourier spectrum, the mathematically precise VP8 distance graph, the 0.2 micrometer superficiality, the binary halftone discoloration, and the forensic reality of the blood precedence, it conclusively proves that no known standalone or composite process explains this image.
Even with refinements?
Especially with refinements. The moment you introduce gravity-draped contact to fix the gas diffusion resolution, you break the continuous topographical math. The moment you introduce heat or chemical washes to fix the browning, you destroy the blood evidence. The analytical filters are working exactly as intended. They are pruning away insufficient theories.
I think where we fundamentally converge, though, is on what the next steps must be. The debate proves we need to move beyond isolated digital models and partial tests. The future requires targeted, minimally invasive experiments on historically accurate, ancient-style linen.
Agreed. Specifically, control the mean diffusion tests under realistic burial conditions. We need to account for accurate drape tension, ancient limestone humidity, and specific temperature curves.
And crucially, those physical replicas must be immediately subjected to fast Fourier transform analysis and digital height map analysis, acting as the modern VP8 equivalent.
Exactly. We need to see if a natural, unassisted chemical gradient can truly produce that perfect mathematical topographical transition without generating a single anisotropic pressure spike. No more isolating variables in a vacuum. We have to test the whole interconnected system at once.
We circle back to where we started. Usually a diagnostic tool or a forensic test brings clarity to an artifact. It points definitively to the tool, the stroke, the process of the creator.
But on the body image of the Shroud of Turin, every analytical tool we apply, from FFT to topographical analyzers, acts as a mirror. It reflects the impossibilities of the hypotheses we feed into it. It is a fingerprint that, according to our current understanding of physics and chemistry, belongs to a hand that shouldn't exist. The pursuit of the unified model continues, but the demands on that model have never been more strictly defined.
It really forces us to ask the ultimate question. Are we looking for a new physical process entirely, or simply looking closer at the ones we already have?
A lingering question, and exactly why we continue the work. Thank you for joining us.